Hey, Ann Pierce, this is Dr. Jones checking in. I have had tech issues, and I think we're actually recording this time. I have given y'all this lecture twice now, and the computer did not record it. So I changed settings, I looked things up, I watched YouTube videos, of all things, and restarted the computer because it was a new operating system update thingamajigger. And anyway, and then I tried it without the earbuds. So we're using the internal microphone on the computer, and I just did a test run with minimal curse words, but actually on the fourth test run finally heard audio. So I'm going to give this lecture for a third time, and it's going to take, because y'all want to know the material, and I want to quit giving the same lecture over and over again. So we are on the top of page 8, and hopefully this will be the end of the tech issues, and I can just sit here and record until the cows come home, or the chickens roost, which actually isn't very long from now. Okay, so the endocrine system includes all, wait, off topic now. Let's see, Dr. Jones checking in, video lecture, AMP2, lecture test 2, video 2, take 3. Endocrine system are all the endocrine cells and tissues that make hormones and paracrines. Endocrine cells, all the cells release secretions into the extracellular fluid, as opposed to the exocrine cells, which release secretions via a duct onto an epithelial surface. Next. Okay, so this bit, let's write down the basic concepts, and then we'll go back to pages 4, 5, and 6 and start filling in columns. So number 1 are the amino acid derivatives that are on page 4, the peptide hormones are on page 5, and the lipid derivatives are on page 6. So let's flip in your note set back to page 4. Again, page 4. So this is the amino acid derivative. Top of the page, I have written down spotlight figure 18 to page 615. So we're just filling in this first column. We'll come back and fill in the rest of it. Some of it this lecture, and some of it not this lecture. At least I've gotten to it twice now. So we have the thyroid hormones. The thyroid hormones are T3 and T4. We will get into what those terms are later. Catecholamines are the middle box. And for that, write down E, NE, and dopamine. We will learn later that E is epinephrine, NE is norepinephrine, not just east by northeast. And that this is adrenaline and noradrenaline. And then on mine, I have a best bracket yet. Oh my goodness, that was totally worth practicing to get a bracket. Sarcasm thought. So little bracket to show that the amino acid that these two are derived from is tyrosine. So as a reminder, amino acids are the monomers of proteins. So these are both derivatives of the amino acid tyrosine. And then we have melatonin, which is a derivative of tryptophan. You've heard of tryptophan because of your Thanksgiving turkey making you sleepy. Although technically, while the turkey does have tryptophan, it's not enough to make you sleepy. It's the sheer amount of food you eat and the fact that you get up at 4 in the morning to cook it. So, and melatonin is what you take when you want to sleep. So that makes sense. So that's page 4. Now let's look at page 5. Flip. Page 5, peptide hormones. So, chemistry talk. What the heck's a peptide? A peptide is a type of bond, and it's a bond between 2 amino acids. Peptide bond. So while our amino acid derivatives were derivative of 1 amino acid, these peptide hormones have more than one amino acid. So the amino acids are the monomers of proteins. Proteins are not fat soluble, okay? If you put a steak in a pan of butter, the steak does not dissolve into the butter. Proteins are not fat soluble, as we've discussed several times, but it didn't record. It's okay, I'm only slightly bitter. All right, so glycoproteins, glyco means sugar, protein is protein. And there are 3 on this list. This is TSH, LH, and FSH. After we've filled in the rest of the note set and you come back to review this, you'll say, oh, that's thyroid-stimulating hormone, luteinizing hormone, and follicle-stimulating hormone. But for now, let's just get the letters written down. And then we have short polypeptides. Poly means many, peptide we just talked about. And so this is smaller than a protein. For these small proteins, you need at least 100 amino acids in a row peptide bonded together. Polypeptides must have less than 100. So the short polypeptides are ADH and OXT. We talked about ADH in the first video, I think. And that's the anti-diuretic hormone. So if you take a diuretic pill, it makes you pee. So the anti-diuretic hormone makes you not pee. And then OXT is the cuddle hormone. Both of these are made in the hypothalamus of the brain and released from the neurohypophysis, the posterior pituitary gland. And the small proteins are growth hormone, which you've heard of, and prolactin, which makes milk. Next page, and we're on page 6 with the lipid derivatives, and I have these words crossed out because it occurred to me that I am never going to ask you any of those terms ever. So, oh look, they're eicosanoids and they're lipid derivatives, and as lipid derivatives they are of course fat soluble. Steroid hormones you need to know. So the first group are androgens. Androgens are made in the testes and also part of the adrenal cortex, so everyone makes androgens. And although they're male hormones because men tend to have more than women, but that's kind of like saying men tend to be taller than women. Not all men are taller than all women, and not all men have more androgens than all women, so you understand how that works. And then estrogens and progestins are made by ovaries, but also the androgens can be converted to estradiol, which is the main estrogen. So again, women have more estrogens and progestins, but typically there are some men who have more estrogen than most women. So corticosteroids, they're steroids that are made in the adrenal cortex. Cortex, get it? And calcitriol, which we will talk about. First, I want you to look how closely the sex hormones are related to cholesterol. You clearly have this same base if we're at playing the spot the differences game between cholesterol and each of the sex hormones. That's what we got. Oh, yep, no, that one's missing too. Okay, so between the estrogen and the testosterone, we're missing a hydrogen, a carbon, and these are the same. So very similar. Next, back to page 8. No, I don't have the page numbers memorized at this point. I don't know what you're talking about. So now we're going to talk about the freely circulating hormones versus the bound hormones. So the freely circulating hormones are released into the bloodstream, used and ditched very quickly. So less than 1 hour, often in just a few minutes. So there are 3 ways to get rid of the free hormones from the bloodstream. One is to bind it to receptors on the target cell and use it for its intended purpose. Next is to filter it out of the bloodstream by the liver and kidneys, which are blood filters. The spleen is also a blood filter, but doesn't help dissolve the free, doesn't help inactivate the free hormones the way the liver and kidneys do. And third, broken down by enzymes. Okay, if it's broken down by the liver or kidneys, it is broken down by enzymes, but in the liver or kidneys. So 3 is broken down by enzymes in the bloodstream. So there are enzymes in the bloodstream to break down the hormones. Kind of like the acetylcholinesterase in the synaptic cleft waiting to eat half the acetylcholine before it reaches the motor end plate. That was a blast from the past. Okay, so that was free hormones. The other are bound hormones, and the 2 hormone classes that are bound are the thyroid hormones, T3 and T4, and that whole group of steroid hormones. So when thyroid and steroid hormones are released into the bloodstream, 99% of them are bound to, they attach to transport proteins, and the transport proteins keep them in the bloodstream as a storage. So it's bloodstream storage of bound hormones. And you end up with several weeks supply floating around in your bloodstream most all the time. Now, the 99% are bound, the last 1% is free. And it's not that the hormones bind to the proteins and they stay there. It's that they bind and then they release, and a different one binds and releases. And so at all times you have roughly 1% free hormones, and those are the thyroid and steroid hormones that are used by the cells. So if at any time you were unable to make thyroid or steroid hormones, you would have a several weeks supply. It'd be a couple of weeks before you really notice the deleterious effects of running out. Deleterious means bad. So, bound hormones, thyroid, steroid, blood supply, well, supply in the bloodstream. Okay, now, bottom of the same page, hormones may, number 1, alter gene expression. And when they alter gene expression, and of course altering gene expression is changing which genes make proteins and which genes don't make proteins. So when we say alter gene expression, we're talking about protein synthesis. And so when you alter the gene expression, you activate or inactivate key enzymes, which are proteins, by altering the rate of protein synthesis. And when you activate or inactivate key enzymes by altering the rate of protein synthesis, you alter the membrane permeability. So what is permeability? Permeability is what gets in or out of the cell. So some of the enzymes might change. Doing this alters the membrane permeability. And you put different receptors and different ion channels in the membrane, and that changes the permeability. So the hormone receptors, moving on, is the protein in the target cell membrane that the hormone binds to. And I'm going to draw us a bigger cell. Okay, my cells are getting worse. And I'm going to draw us an extracellular receptor, and I'm apparently going to write the word extracellular, but I don't like the red. I didn't like the red the last 2 times either. I remembered sooner this time. Blue. There we go. Blue looks better. Extra. I'm writing with the mouse. I apologize. I mean, my handwriting's terrible anyway, but C-L-L-U-L-A-R. I'm an oral learner, so I spell out loud. Extracellular receptors. C-E-P-T-O-R-S. So the extracellular receptors should be familiar from last semester, like acetylcholine binding to an acetylcholine receptor, and all the synaptic cleft stuff and that we did last semester. And they were all extracellular receptors. There were receptors that were studied in the cell membrane, but the part that the chemical bound to was on the outside of the cell. So that's the hormone receptor. We will also have intracellular receptors that are inside the cell, but we'll get there in less than 5 minutes. So down regulation and up regulation, you can change the number of receptors on your cell membrane. Down regulation is when there's been too much of that hormone readily available, so your body starts taking in the receptors for that hormone, so that while there's too much hormone, you'll be less reactive to it, less receptive, if you will, since you take away the receptors. Okay, that was terrible. Upregulation is the opposite, is when there's not enough hormone, so your body builds new receptors, and I mean lots of new receptors, so that if any wandering molecule of that hormone floats through, your body can respond to it. And that's part of what they recommend with early stages of diabetes mellitus, where you're making insulin, but your body is less receptive to it because you have, to a degree, down-regulated. Because there's been so much insulin in the bloodstream for so long, the body starts pulling in the insulin receptors because it was too much. So you down-regulated. So that's why they'll often suggest first diet and exercise if you're not insulin dependent. I'm talking about type 2 diabetes, not type 1. And diabetes mellitus, not diabetes insipidus. We'll get there. That you quit sugar entirely for a couple of weeks in hopes of up-regulating and building new insulin receptors on the cell membranes. Okay. You know what, flip to page 4. Let's fill in another couple of columns, and then we should be about done. Did I not start a timer? Oh, that was the last time. The last one I started a timer. Okay, well, we're close to 20 minutes. I lost my page 4. Oh, there we are. Page 4. Okay, so we're doing the not the thyroid hormone, because that's complicated. We'll get there next. The catecholamines and how they work. So how do catecholamines work? Well, they're extracellular receptors. And why? Because they're not lipid soluble, as we discussed. And how do they work? Well, it's an indirect thing with the neuromuscular junction. We had the extracellular receptor, and it was a sodium ion channel. And so the sodium went through that same channel. This is a different story entirely. Remember our cyclic GMP with the other bit? So you activate a G protein, and then the G protein diffuses to an ion channel and opens it. And there's a number of different second messengers available. We're not getting to that level of detail. They all involve a G protein. Gus Duson's, we're going with it. Our book is oddly silent on how in the heck does melatonin work. So I have taken this opportunity, the last 2 times we had this discussion that it didn't record, to talk about the extra credit essays. So science is about asking questions and looking for answers. Science class is about memorizing stuff that someone else had the fun of discovering. So in an opportunity, in a chance to give you an opportunity to ask questions and look for answers, I have our extra credit essays, where when we come to a topic and you're like, wait, how does that work? But our book doesn't cover it, that you can do some research, Google it. Find some information that you didn't already know. So if you find information that you didn't already know that's not part of our class, you can write me an extra credit essay, at least a paragraph, less than a page, and turn that in for extra credit. They tend to be due at the beginning of the test. So again, don't write me the book. I've read your book in the previous 3 editions before this book. So like, no. Teach me something new. Now you may use our book as a source, specifically as a source of ideas, and then go research something. Okay. And watching YouTube videos does not count as research, unfortunately. Next page, she says on a YouTube video. Peptide hormones, extracellular receptors, not lipid soluble because G protein. Ooh, this is different. Remember, we don't need that. These are intracellular receptors because they are lipid soluble and they do diffuse across the plasma membrane. So these are the ones that I mentioned where it's still studied in the cell membrane, but since these eicosanoids can float through the cell membrane like it's not even there, the receptor is on the inside of the cell membrane. Fun, right? Okay, so we are going to call it there, and we will start back in at the top of page 9, where we will say things that we already said, except we'll get them written down in a note set format. So I'm still a little salty about all the recordings. That's the first 3 I had to redo because I hit the wrong button and there was no audio. And then there was another one with the weird bird alien audio, so that was 4. And then this one twice, so that's 6. So maybe I've learned what I need to know, and hoping against all hope that this internal audio has worked. And okay, I'm going to get off here so that I can upload this to YouTube and record the next one. So this has been video lecture for AMP2 test 2 video 2 again, and covering page 8 and a few columns of 4, 5, and 6, and we will come back with video 3 and page 9. So thank you as always for tuning in. I appreciate your patience, and remember, the world, as I'm recording this, the world's gone a little to the crazy side, but the world always needs healthcare. Nurses and rad tech and all of it, OTAs, PTAs, even coaches and firefighters. The world needs y'all. And so the education must go on. Thank you as always for tuning in. Dr. J out. Okay, Command Control Escape, and it's going to come up with a recording this time.